students, we're back at it again with another video. This week we're going to tackle some more derivative problems. Let's get started. Okay there students, so today I want to go over another type of a derivative type of a problem where we have multiple functions composed of one another. So over here I have all the tools we're going to need in order to take the derivative of this function here. Over here I have all the derivative rules of specific types of functions, derivatives of polynomials, derivatives of exponential functions, logarithmic functions, and sinusoidal functions. So those are all the derivative rules that focus on individual types of functions. And then there are general derivative rules which apply to all types of functions, the product rule, the quotient rule, and the chain rule. However, today we're going to be focusing more on how to really use the chain rule to take the derivative of a complex function such as this guy here. So the chain rule states that if I do have a function that consists of one function composed of another one, the derivative of that function is the same thing as me finding the derivative of the outer function, then multiplying that by the derivative of the inner function. However, over here, things are a little bit more complicated. There is not just one outer function and one inner function. There are actually multiple functions being composed of one another here. So the way we would take the derivative of that, well, let's just kind of apply the chain rule to, let's say, just three functions. Then we'll probably see that there's a pattern. So if I did have a function that had some outermost function f of x, and then inside of that was g of x, and then furthermore inside of that was h of x, the derivative would be as follows. I would take the derivative of the outermost function, which is basically just me taking the derivative of f of x while keeping g and h completely still within it. Then I would take the derivative of g of x with h still inside of it. And then finally, I would take the derivative of h of x. So it looks like the main crux of, or the main type of understanding for taking the derivative of many composed functions is to start with the outermost function and then work your way in. So it's going to help out a lot if we can at least kind of point out what the outermost function is and what the innermost function is, and then what all the functions are in between that. So what we're going to do here is we're going to break down how many functions we actually have inside of here. So let's start with the outermost function first, which I'm going to call the first function. So the first function, if we look at it, it looks like all these logs and these sines and this base of 4 and this cos to the 3x, it looks like all of it is inside of a bracket raised to the power of 5. So actually, our first function is actually a polynomial. So that's good to know. And I know that if I want to take the derivative of a polynomial, all I got to do is take the exponent and multiply it by whatever coefficient is in front of that polynomial, and then subtract the exponent by 1. So over here, we can think of this log 5 of sine of 4 to the power of cos to the 3x. We can just envision that as the x here. So what we're going to do to take the derivative of the outermost function, which I'm going to call first prime. So I'm no longer going to say this is a polynomial. I'm going to kind of structure this. I'm going to say that my first function is actually just this whole thing. Bear with me here. So this whole thing is the first function. And if I want to take the derivative of just the first function, I'm going to call that first prime. I'm just going to treat the log and all this stuff as like a stuck variable. And I'm just going to take the derivative of the polynomial. So I'm going to take this 5 and drag it onto the front. Then all this stuff is going to stay the way it is because I'm not taking the derivative of this stuff yet. But now this power of 5 will change to a power of 4. And now we have the derivative of our first function, Now we're going to slowly move in more and make until we take the derivative of all of the functions which are inside of f of x. So let's change our color here. The second function. Here, the second function, if we kind of work our way from the outside in, the outermost function was the polynomial here. Inside of that, the next thing I see is this log function. So the second function is all of this log stuff. Log base 5 of sine of 4 to the power of cos 3x. Alrighty. There's our second function. So basically, I just need to take the derivative of this log function now. So the derivative of a log function is as follows. As long as I know the base and that value of x, I can take the derivative of it just like I did over here. So here we have the base of 5, and the x is just going to be all of the stuff over here. All of this stuff is going to be counting as that value of x. So when I take the derivative of this log function, I don't need to touch this stuff here. So the second function prime is going to be 1 over the base of the log, which is 5, times the ln of the x, which is essentially all of this stuff here. Sine of 4 cos to the 3x. And there's a derivative of our second function. All right, now we need to keep on going. Let's change our color again. Now we need to take the derivative of our third function. So the first function was the polynomial here. Then the second function was the log. And now if I keep going further in, the next function I would have to deal with is this sine function. So the third function is the sine part. Sine 4 to the power of cos 3x. And then for me to take the derivative of a sine function, the derivative of sine of x is just cos of x. So my third prime is going to be equal to just cos of all of this stuff. Because I'm treating the 4 to the power of cos 3x as this x here, and I don't want to change it. All right, now we're kind of getting on our way. We're almost done. We just have a couple more functions to take the derivatives of, and then we can combine everything into one final statement. So our fourth function. Our fourth function, so the first function was the polynomial. The second function within there was the log 5. The third function was the sine. The next thing inside from there is this exponential function of 4 to the power of something. So we got 4 to the power of cos 3x. I know that the derivative of an exponential function, b to the x, is as follows. So the fourth prime is going to be equal to ln 4 times, and in this case here, that x is just going to be the cos to the power of 3x. I'm not touching that yet. And there's a derivative of our fourth function. All right, we're getting closer and closer to being done here. You just have a couple functions left. Alrighty. So the first function was the polynomial. Then the second function was the log. Then the third function was the sine. Then the fourth function was the exponential of base 4. Inside there, we need to look into the exponent now. We have a cos to the power of 3x. So that's our fifth function. Whoops, hang on guys. I just want to change the color here. There we go. So our fifth function is the cos function, cos to the power of 3x. To take the derivative of that, I know that the derivative of the cos function is just the negative sign. So just negative sign, not touching the 3x part, 3x. All right, guys, we have one more function left. So the first was the polynomial, then the log, followed by the sine, then the exponential of base 4, then the cos function, and then finally, inside of the cos function, we do have one function left. That sixth function is actually just going to be 3x. And 3x is just a polynomial. You take the derivative of that. All I got to do, I can assume there's a power of 1 here. I can drag the power down. 1 times 3 is 3. Then I would have technically x to the power of 0. But x to the power of 0 is just 1. So I just got 3. And now I have all 6 of my derivatives within this giant composite function here. So finally, I can say that f prime of x is basically just going to equal the first prime. And then from there, times the second prime, times the third prime, times the fourth prime, times the fifth prime, times the sixth prime, etc., etc. So typically, if you organize your stuff like this on the page, your teacher might even let you answer the question like this. But at the end of the day, you could just easily just slap all these primes together using multiplication. And that's how you take the derivative of an extremely composite function. You just start from the outside and work your way in. And if you organize yourself like this, it's never going to be too difficult to figure stuff like this out.
Well, there you have it, students. Once again, it looks like breaking things down into smaller steps will always make things easier for you. If you found this video useful, please like the video and share it with your friends. If you have any questions about the material we covered today or have a similar problem, leave a comment down below and it could be your problem that we tackle in the next video. And remember, whether you're struggling in school or just want to get ahead of the curve, we have many amazing options available. Book a session with us now.